What if you could build an app just by describing what you want it to do in plain English? And I don't mean chatting with an AI assistant. I mean writing English that gets compiled directly into a real high-performance program. Today, we're going to dive into Lingua, a project that's trying to do exactly that.
This right here, this is the core idea, and it's a huge shift in thinking. For decades, programmers have had to bend their minds to fit the rigid rules of machines. Lingua just flips that whole concept on its head and asks, what if the language bent to fit us?
Now, I know exactly what you're thinking. Hey, I can already ask a chatbot to write code for me, so what's the big deal? And that is the most important question, because the answer is what makes Lingua so interesting. It's defined not just by what it is, but maybe more importantly, by what it isn't.
So, to really get what Lingua is doing, we first have to talk about the path it's decided not to take. You see, using a giant AI model like GPT as a compiler, it sounds like the obvious move, right? But it's actually packed with problems that make it a total non-starter for any kind of serious professional development.
This table really breaks it down. A typical AI approach just doesn't work for a compiler. First off, you'd need an internet connection for every single build. The API costs for a big project would be absolutely insane. But the real deal breakers are even more fundamental. It's non-deterministic, which means the same English could spit out different code each time. It's a black box, so if something goes wrong, you have no idea why. And you're sending your valuable source code to a third-party server. That's a huge privacy and security nightmare.
So, if a giant AI is the wrong tool, what's the right one? Well, this is the core insight of the entire project. When we write instructions for a program, we're not writing a novel or a poem. We're using a very specific, limited, and predictable subset of English, a constrained dialect full of commands, conditions, and names. And because it's so constrained, you don't actually need a massive AI to understand it. And that brings us to the heart of the machine, the translator layer. This is Lingua's secret sauce. It's a completely deterministic system built from the ground up that runs entirely on your local machine. No API calls, no machine learning models. Let's pop the hood and see how it really works. The whole process works in 3 logical steps, a lot like a traditional compiler. First, something called the Lexer breaks our English sentences into meaningful chunks. Then, the grammar engine figures out the sentence's structure and what it's trying to do. And finally, the semantic resolver acts like a proofreader, checking to make sure everything actually makes logical sense.
All right, let's start with the Lexer. When it reads a sentence like create a button called submit, it doesn't just see a string of text. It sees categories. It instantly knows create is a command, button is a type hint, and submit is an identifier. It's basically figuring out the parts of speech, the verbs, the nouns, the proper nouns of the instruction before it even tries to understand the whole thing.
And this is a perfect example of that non-AI approach. The Lexer isn't guessing. It's a super high-speed rule engine that uses a custom 2,000-word dictionary. This makes it incredibly fast, and more importantly, it's 100% deterministic. The same sentence gets broken down the exact same way, every single time. No randomness at all.
Okay, so once the sentence is tokenized, it's passed on to the grammar engine. And this isn't some new, unproven technology. It uses what's called a context-free grammar, or CFG. This is the exact same battle-tested technology that has powered compilers for languages like Python, Java, and C for decades. It's designed to recognize valid patterns, like command an article, then a type hint called an identifier. So once the grammar is confirmed as valid, the semantic resolver steps in for the final logic check. It handles things like scope resolution. So if you say create a button, and then in the next line say change its color, it knows that it refers back to the button. It also catches you if you try to do something impossible, like adding a number to a piece of text without converting it first. Now, the crucial point here is that after these 3 steps, we get the final product of the translator, an abstract syntax tree, or AST. The best way to think about an AST is as a universal, logical blueprint of your program. It's not code yet, it's just a pure representation of your intent, and it's completely separate from whether you want to build a website, a mobile app, or a desktop program. Okay, now for the payoff. We have this universal blueprint, the AST. So how do we turn that into a real working application? Well, this is where Lingua's versatility really starts to shine. Let's look at a super simple example, a basic counter app. The source code, written in a .lng file, is just plain, readable English. Create a number variable called count with a value of 0. Create a button called increment. When the increment button is clicked, add 1 to the count. I mean, come on, it's so simple and straightforward. Anyone can understand exactly what this is supposed to do. And here is the magic. From that one simple English file, Linguist Compiler can generate native code for pretty much any target you can imagine. It can spit out JavaScript for a web browser, Swift for an iOS app, Kotlin for Android, and even a native binary for desktop or server apps. It's one source of truth for multiple native outputs.
And what does that output look like? Is it a mess? No way. The compiler generates clean, well-structured, human-readable code for each target. It doesn't just translate words, it actually engineers a proper solution based on our English instructions. This is that aha moment where it all just clicks into place.
So when you put all of this together, it's pretty clear that Lingua isn't just another programming language or some handy tool. It's a genuine attempt to fundamentally rethink the entire relationship between us humans and our computers. And this isn't just some theoretical exercise. The performance targets are serious. The goal is to compile a 1,000-line Lingua program in under 200 milliseconds. We're talking less than the blink of an eye. This is being built as a practical, fast, and efficient tool for real-world development, not some slow academic curiosity. Ultimately, this is the perfect way to think about it. Lingua aims to be a direct bridge from human intent, the idea in your head, to machine execution. It wants to remove that thick, complex layer of formal syntax that has always stood between our ideas and a working program. And that leaves us with a pretty fascinating final thought. If the main barrier to creating software was no longer learning a complex artificial language, but just being able to clearly describe your logic in your own native tongue, what would that future look like? What if programming became a universal skill, truly accessible to anyone with a great idea?